All right, hey people. Okay, let's move this once so I don't have to do this 20 times. We good, Thor? Yeah? All right, cool. So, I'm doing a talk on, I gotta talk this way. This is gonna be annoying. Okay, fine. I'm doing a talk on reverse DNSing the world, specifically, yeah, we'll get into that. But there's lots of stuff you can find in reverse DNS records that may or may not actually be a good idea to put into DNS records publicly. And you can use it as a targeting vector as well if you're looking at scanning a network or finding certain devices. Yeah. Very small amount about me. I'm part of these orgs, or was. So I work for I don't work for Northforge. I run my own public cloud hosting company, part of sort of DC 204. We're going to try and get legal documents for incorporation done today. I'm part of Coldhak. Was CTO at Price-Razzi. I'm a past board member at SkullSpace and MUUG. I'm around the community. Say hi. I'll talk to you about anything, really. I wanted to put this slide in to remind me, I don't know who else is going to do this, so I'm just going to do it now. But I know for a fact that the organizers have put way more time into this event than it is reasonably to expect. So I want to thank those organizers, because the people with the red shirts have actually made this event possible. Thank you. Yeah, and they really have made it possible. Without that, I'm close enough to them in terms of friendship. I hear all the horror stories, but I'm not responsible for it, and I'm not, So I can tell you that it's a lot of work, and that they did a good job. So anyways. All right, so standard, I'm not liable. That's a lot of small text at the bottom. I just wrote some shit down. Don't blame me. You do this shit, it's not on me. We good? Yeah. No. You can blame me all you want, but legally, it's on record, not me. And also, more to the point, I represent, in roundabout fashion, a whole lot of different startups and orgs, and myself and my companies. It's not them. This is me. So don't bias your interpretation of any of the people on the previous slide with this. All right? Yeah. So there are, give or take, 3.7 billion public v4 addresses. And it's important to note that I'm talking about v4 only in this talk, because it's infeasible, and I'll get to why, to do the exact same thing I just did with v6. It's just not possible. I got to that number as opposed to the actual total spec based on taking RFC 1918 address space and subtracting it. Basically, it doesn't make sense for me to scan and try and look up reverse DNS records of 192, 168. It's going to be different everywhere, and it's not going to be public. And this is all just public addresses. Yeah, and it's a lot of records. So if I'm going to store this stuff, it's going to be a lot of records, right? Everybody understand that? 3.7 billion things of anything is going to be a while, and it takes a lot of space. It's just not. So I happen to be able to do this because I have a decent internet connection, and I've got my own hardware and space and everything else. So it works. I'm able to do this. Yeah, I put this in. What the fuck is RFC 2317? Hey, can I swear on this? Rylan? Yeah. Good, awesome, thank you. Sorry, I think I should check.
A lot of things, but that's okay.
Okay, awesome. So that means that I can actually verbatim talk. Again, I don't represent my org right now, and I'm still drinking coffee, so I'm going to be grouchy. RFC 2317 is a thing. There you go. Seriously, it's a thing. It basically defines that in-adder.arpa exists and does something special. So when you look up, everybody has a general idea of how DNS works, I'm hoping in this room. Yeah. Awesome. So you look up a forward record, and you basically go, oh, hey, I want to get to Google. What's the IP address? And you ask a DNS, and it goes up the chain and back down. And if you want to do the inverse of that, as in I have an IP address, and I want to look up what domain it goes to, you actually basically flip the address around. So if I had 1.2.3.4, I would actually look up 4.3.2.1.in-adder.arpa, and I'd send that request off to my DNS resolver. And that would go up the chain and back down. And it's a top-level domain, ARPA, because, well, this comes back to a long time ago when ARPA was still a huge piece of the internet. And it still is because of this stuff, right? But that's how you get it. And you get a PTR record. And you can have more than one. This spec basically says that you should. In RFC parlance, this is a should and recommended, but not mandatory thing. Yeah. And basically allows you, it's used a lot. You'll see this, you will interact with reverse DNS specifically around mail and validating domains and IP space, mainly because it's how you can prove globally that you actually have access to that particular, like this is me, right? My IP address is this, and this is my domain, and therefore it works. Yeah, sort of. So I'm going to go over the stack I'm going to use quickly. So very briefly, the whole point of this, and it's not actually in my slides, and I haven't mentioned, I reverse DNS the entire v4 world, created a database, and then you can search it and do some random stuff with it. So I'm going to go through the stack of how I did this. And then there's about half the slides are like neat shit I found. And if the demo gods are feeling nice, they can come and bless me with a live demo. I have it working, and I will take random suggestions on things to look up and see how stupid people are. So the stack. Can't really see that well, sorry. Basically it says mass scan, queue, DNS query, Elasticsearch. There's some little bits in there that I'll go over sort of, but the basic idea is mass scan's pretty awesome. I've got a whole bunch of slides in here about that, about how I did it. It allows you to spit out shit tons of IP addresses in a random fashion, but still in a set. So it's how I could generate every single public v4 address that's public in certain ranges, but have it be randomized so I don't just enumerate every single IP address one by one by one by one, because people are going to think of that as a denial of service, right? I'm hitting the same DNS server with every single query of that. They're just going to be like, no, fuck off. Like, go away. I had to use a queue because, well, it's CPU intensive. DNS query exists. I'll go through that as well. And then I am a JavaScript whore. I'll just come out and say it. I like JavaScript. So Elasticsearch is a NoSQL database. It scales really well, also this shit. But it works really well to put this kind of data in it. Okay? Yeah, that thing. I'm going to go over what that is. Basically, it's mass scan. I'm going to go, yeah, we'll go over what that is. So it's Rob Graham. If you Google mass scan, see if you can find his DEF CON 23 video. It's on YouTube. It's really awesome. He does mass scan and scans for VNC, like straight up open VNC, runs it through a series of things, and then ends up with, here's this real time, click, there's an image that somebody didn't lock down their VNC thing in. In the demo, he randomly clicks on one and ends up with a train. This is a train control system that he found with mass scan. You can think of mass scan and like the inverse of Nmap, sort of. It's sort of like it, but instead of using a small amount of hosts and a lot of ports, mass scan scans a whole lot of hosts and very few ports. Yeah, scans large IP ranges quickly, and I mean very quickly. And the sets are really nice. And the real gem in this whole thing is the randomization math for getting a huge amount of IP space generated in a random fashion, but still keeping it within these prefixes and within this set. So I can say, oh, I want to have the 10/8 range, but exclude 10.2.3.0/24. It will do that for me, but it'll do that in a very efficient fashion. Keep in mind that this is an algorithm, because even storing every single v4 address by itself will be hundreds of gigs. So it's an algorithm that generates it, and it matters. I couldn't find anywhere else that was doing this. So the algorithm has now been ported to like JavaScript and C and all this other random shit. It's in C here, anyways. Yeah, it'll do over 10 million packets per second on hardware that is actually set up with a like PF ring system. So that's 600 megabit of 64 byte packets. That's a lot of network traffic. It's enough to kill most things. It's enough to kill most networks. Your ISP upstream will hate you if you do this. And their ISP will probably hate you if you do this. To do this at scale, you really do need a very friendly ISP, and they have to have a good relationship with their upstream. Because you are sending a lot of very small requests, one packet per IP address, basically, going out the door. So it's a lot to get this done in a reasonable time frame. By the way, that means that they can scan with mass scan and it's tweaking whatever else. You can get it done. You can scan the entire v4 space in about 5 minutes, which is pretty cool. How many web servers are there on the internet? Oh, by the time I've been talking up here, you could have scanned it twice. Out of the box, it'll do about 1.6 million packets per second. Pretty good, right? We're going to go through this, because this is basically what I used to get this front end of this whole process going. And I'm going to start speeding through this, because I really want to get to the demo. So I'm lazy. Yeah, why write really good code? I've had titles of developer, sysadmin, blah, 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 CTO. So I actually can write good code, but for my own projects, I'm lazy. So I wrote one piece of code that shoves it into a queue. So it takes the output and shoves it into a queue. And when that runs for about 48 hours and you have a memory leak and you don't want to diagnose it, why don't you just shard it? Because mass-scan has an option, and then you just execute that same thing like 1,000 times in that process, and your memory leak doesn't really matter anymore. So that's why that exists. That's how I did it, because screw good code. Let's just, create a bash loop and just do this. Mass-scan, when it does subset, right? Specify range or multiple ranges. This is the entire world, right? So it's the subnet. Yeah, you can exclude things, which makes sense, right? When you're scanning using mass scan proper, you probably don't want to scan Department of Defense and Ministry of Defense and take your pick of 3-letter agencies. Well, they take not that kindly to it. So you can do it, but you will get some nasty letters. According to, I've done this a few times. I haven't gotten any letters because Masscan actually collects a list, puts it in their GitHub repo of, these are the networks that have asked us not to scan them. And it's just common fucking practice. If you're going to bother to do this stuff, don't be a dick. Because if you be a dick, people are going to come find you and be like, no, and they'll talk very nicely to your ISP, and your ISP will be like, okay, well, I got a nice letter saying I have to drop you. Not actually the case, but it could happen, and they can make life hard. So make life nice. And this actually applies to educational institutions as well. There's a lot of educational networks that are very large, and they have automated systems that will come back and say, hey, you scanned me, fuck off. There's a nice list that actually basically you just go and say, okay, well, this guy asked not to be scanned. I'm not going to scan him. Right? Simple enough. -SL, one of the nice things about mass-scan, a whole bunch of options. SL will output every IP address that it would scan normally onto standard out, which is really nice. Really, really nice. And it outputs some bullshit to standard air, which doesn't have options to kill it, so just screw standard air. Pipe, yeah. Running that, and I piped it to PV, also screw PV with the default rate in bytes, not bits. If you don't know what PV is, you pipe it to PV, and it'll tell you what the bandwidth is going through that pipe, and it just outputs that to standard air and copies the input to the output, so you can put it inline. But it does like 35 megabytes per second on my laptop, generated from a single command. So it's a lot of data, and you need some way to eliminate that down, right? Yeah, so Rabbit Pipe. I created this. It is available right now. It does work, and it works rather well. I actually put tests into it. But basically, it takes standard in, and with some options, blah, 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 it will kick it to a queue. Every line kicks to a message in a queue. That's important because this script will actually, you can set a limit on how big you want that queue to be, and it will actually pause the read line. So like, you know how a pager, you use pipe less or pipe more, and suddenly if you do that in a running process, eventually, and you leave that like in a tmux somewhere, and it'll just break later on, that's because it's actually paused, and the program has been told, oh, when you try to write standard out or standard error or whatever else, it's just like, no, buffer's full, hold on. That's useful because mass-scan is designed to handle that. So you can actually pipe it to less and scroll through the infinite, or you can pause it. So this allows me to put everything in a queue without the queue being massive, because I can't handle that much IP space that quickly, right? This is a limiting factor. All right, cool. And that's how you can say hi to a queue. Basically, you specify a producer mode. You can also specify consumer mode, and you specify the queue and some defaults and blah, blah, blah. And it's an idea, right? So you can just, anything you put in, shove it there. Yeah, so back to this. That's what it looks like, sort of. This was yesterday when I did another test. This is RabbitMQ's admin stack, but you can see it just basically, oh, look, there's stuff in the queue, right? Particularly IP addresses. So that's bottom right over there. You can see a random IP address. Yeah, point is that I just put every IP address in a queue. And back to this whole thing. So we covered mass scan, got to the queue. Awesome. Power DNS. So once you got it in the queue, you need to pull it off. So that's why I used a queue, because you can use multiple things to pull it off. Yay, workers are good. Pool of workers, even better. To look up all this stuff up, you need to use DNS. So run your own DNS server. Whoa, maybe? Come on. Oh, we're just going to do this. I'm going to do it on time anyways. All right. I got to power through this quickly. All right, so you use Power DNS recursor. You can have multiple instances of it, and a thing called DNS dist. Power DNS, multiple processes, multiple resolvers, and then, yeah, because they're going to be heavy CPU load. And DNS dist basically does this. Everybody got that? Things, one in, round robin, all kinds of cool rules, not going to go into it. It's CPU heavy. That's a 60-core system. Again, I run a public cloud hosting company, so I can actually do this without paying through the nose. But that's as it starts up. I have, goddamn HDMI. There we go. Anyways, you end up with lots of CPU usage. You end up, once you pull it off and do the query, and then it comes back, you shove it into Elasticsearch. What the hell is going on with this shit? It's not my laptop. All right. So, yeah, you got some records in a database. This is Kibana. It makes it look pretty, but it's basically Elasticsearch. Size of a record is, any guesses, really quickly? Average reverse size DNS record.
512 bytes.
512 bytes? No. What?
64 bytes.
64? No. It is 150.3. That's important because when you're dealing with large data sets, I had to do a sample size and limit it to like 10% of the internet, because otherwise it's like, oh shit, I just filled my disks. Yeah, that comes out to like 500 gigs of data, just that data. And you can get it down using compression and all this other stuff. Ask Mac about gray codes. He's over there, one of the red shirts. Anyways, yeah, I set up Kibana, and it stalls at 14%. And I'm basically like, what the fuck? What did I do wrong? Well, it turns out, no, that's how many records there are, because it's not a requirement. So there are actually a lot fewer reverse DNS records than there are IP addresses. Makes sense. So now we get to the fun part. So I'm going to whip through these really quickly, and then I'm going to do a live demo and show you guys, take random suggestions. So we got card. What happens if I search card, like every single reverse DNS record, and get card? Well, you find shit like this, which if you can't, people can read that, sort of. Basically card readers, swipe card, card access, and Micros credit card machine. All of these these are the kind of things that you probably shouldn't be public, that this is their IP address. At the very least, you should just like have a reference table and just do the lookup that way. It's just basic shit, right? Like, don't provide a target. If you, yeah, door. Yeah, chemistry doors, door access, a whole shit ton from EDUs, because, you know, they use reverse DNS and they know what they're doing, so they use it properly, which also means that you can do this. So if you wanted to denial of service a door, you could do it, or just hack a door. Android. How many people do you think take a public v4 subnet and bridge it to their Wi-Fi? So that if you just connect to the Wi-Fi, you get a public v4 address that routes. Yeah, lots of EDUs, but there's stuff in Brazil and Netherlands, and a whole, like, literally tens of thousands of these things. Room. Central control room sound, not that big a deal. Control room shit, all this other stuff, yeah. Printer. Yeah, these are bad. Again, whole thing of reverse DNS, you probably don't want this public. I'm going to get to it. Wait, I think it's, yeah, okay. So I'm going to make a note now. There's way more of these things than I can list. The ones I'm showing you are the ones that I could ping, which means that they don't have a firewall in front of them. And there are tens of thousands of those, okay? So, yeah, okay. UPS. How much time do I have? 5 minutes, 10 minutes? 5? Okay, we're going to go through this quickly. UPS. Yeah, lots of UPS systems. Don't do this. Random stuff. What's on here? Yeah, thermostat manager, stupid user registered this, stupid and happy. That's from a Navy.mail, which got in there somehow. Flight boarding kiosk. I was talking to somebody earlier, I think it's Tim, who does stuff in North Dakota and Minneapolis. That's MSP, so if you happen to have that client, take a look. Temporary Kibana VM, a whole bunch of shit, right? Okay. Grab your reverse DNS record, search each string, feed that script into a shell script, get the results. So that's what that does. Basically, you say, search for printer at the end of it, it will search the database, stream in parallel 20, and grab the IP address and run it as the first argument to the script you specified. Allows you to see, make a filter basically, right? That's the simple exit 0, 1, all this other shit. Live demo, okay. Did I sacrifice enough to the demo gods? Okay, so I'm running this on a tunnel. So last 90 days. Here's this query right here. Yeah, I'm on. This is my SSH tunnel. Notice the CPU usage. That's Elasticsearch, just like CPU pinning the shit out of those things as it indexes it. It's not doing live indexing, but other fun things that I happen to find. This is just bullshit working notes. There's random shit in here like car door. There's a whole lot of honeypots out there that are like straight up like, I know this is a honeypot. It says that it is. Backhaul BGP cacti. Take your pick of what you want to Google or what you want to search for. So here's an example, right? So this whole thing. So it takes a while. I had it set to something reasonable like 30,000 packets per second. Once this actually loads this, we'll get into, I'll take random questions. So start thinking about what you want me to search for, and I'll show you how many there are. All right. Yell shit out. What do you want me to search for? What? Vault? Vault. All right. That has 175 results, and you probably want the reverse DNS record in there. I saw ATM in there briefly. That's not good. Okay, next. Oh, fuck off. Docker, okay. Daycare? Yeah, York University, daycare. Oh, yeah, here's a bad one, sorry. This right here, FNAL, they bridge their Wi-Fi and they use reverse DNS very properly, but that's the Fermi National Accelerator Lab. You can ping every Wi-Fi device on there and like, yeah, all this other shit. Okay.
CERN.
What?
CERN.
CERN has lots of stuff on here because they have lots of space. I'm going to do Reactor because I'm kind of cute. That's R-E-A-C-T-E-R-O-R. Thank you. Yeah. It's like, I know that's it. Gov.mb.ca. Here's all the government of Winnipeg stuff, or Manitoba. It's better if you do something like Manitoba. Dildo? Dildo. That makes sense, right? So you've got websites that have the reverse DNS of dildos.com is a thing. Yeah. ATM? ATM, you're going to have lots because you're going to have ATM traffic as well. Oh, no, you don't. Oh, there it is. Yeah, so you can get lots of shit. Am I out of time now? 1 minute? Okay. So you can. I'm just going to summarize this up. You can get lots and lots and lots of stuff out of this and use it as a targeting mechanism. You can also do some really cool shit like, well, pretty much anything you want. You want to, like, you could mash this data up to geographical area to say how many cameras there are. Like, camera. Yeah. It's going to take a few seconds. There we go. That's not bad, actually. That's not bad at all. 640 of them. There you go. Cam has 4,000. How about Linksys? You can find stupid people. Linksys, localhost. These are public address. Yeah. 600,000 people decided to publicly say this address is actually localhost. Or how about API and dev? There's all the dev APIs. Target away. You can do some really cool shit. I'm done, right? All right, cool. Question or two. Any questions? Wow, that was easy. I will make this available and send a note out to BSides, the database itself. It's actually about 300 gigs, something like that. Compressed, it could be a little bit more less. You can actually do this yourself, and there are other places that, if Mac was helpful enough to let me do that, if you talk to the right people, there are nonprofits, but you have to say, like, I'm a security researcher, here's my creds, and you can go and get access to that. I did it myself because I could. So the question was, how do I get access, by the way? Yeah.
Do you keep previous results, perhaps compare them to see what's changed?
You could. I'm lazy. I didn't want to do this too often, and I hacked this together because I was like, oh shit, I actually got accepted. I should actually do this. So the question was, do I keep historical results and then compare them? You could, and it would be useful, and you can see changes between you could use that as a way to discriminate people bridging onto their own devices. So it would be very clear that this particular subnet is just devices, Android and iOS, because they change a fair bit. Cool. All right. Thanks, guys. See you later.